doing the postulates of Dalton atomic theory. Okay. Did you revise the previous notes?
Yes, ma'am.
Okay. Can I ask some question, please?
Okay.
Yes. Okay. So please tell me. Wait a minute. Atoms and molecules. So tell me, what was the two laws of chemical combination? I just want a statement. Okay. The first law.
Okay. Atoms can neither be created nor destroyed in a chemical proportion.
Okay, good. For this, I told you about the two experiments. Okay. The weighing scale and the flask was there, and we were having two solution, CaCl2 and Na2SO4. Okay. Previously,
Yes, ma'am.
previously before mixing they were having a weight of 300.23 grams, but after mixing the solution,
They were
okay,
same.
they were same. Okay. So this hence the statement is correct, that is the total mass of the reactant is equal to the total mass of the product. Okay. Now the second law, tell.
Uh, in a chemical substance, um, the elements are always present in a definite proportion.
Yeah, in a chemical reaction, the elements are present in a definite proportion. Okay. Now we were doing the Dalton's atomic theory. In that, I told you about how much? One, two, three, four postulates. Okay, you have to learn all the postulates in a line wise. Okay, they will ask what was the second postulate of the Dalton's atomic theory, what was the first postulate, what was the last postulate. Okay, so try to remember the postulates by its number. Okay, wait, this is first, this is second, this is third, and this is fourth. Okay.
Okay, ma'am.
Okay, uh, firstly, I am revising all matters is made up of a very tiny particles called atoms. Okay. This I told you, atoms cannot be created nor be destroyed, and they are very invisible particles. Okay. Now the third postulate was the atom of a given element are identical in mass in a chemical reaction. Okay. And the fourth is atom of different element have different masses and different chemical properties. Okay. Now the fifth postulates. Take out your notebook. Write it where you have stopped. Okay.
Okay.
Okay. Okay. The fifth postulate is atoms combine in a ratio. Write it. Then I will tell you the meaning. Atoms combine.
Ma'am, can you wait? I just want to get my pen.
Okay. Okay. Meanwhile, I am writing. Okay. Atoms combine in the ratio.
Yes, ma'am.
Okay. The next postulate is atoms combine in the ratio of a small whole number to form compounds. Okay. I'm writing compound in a short form. Okay. You have to write the full spelling COMPOUND. Okay. Write it, then I will tell you what does this states.
Okay. Mhm.
Okay. This means what does this line mean? This line means when atoms join together, okay, they form a new substance, a compound. Okay, they form in such a way that they can be counted using a simple whole number. What does it mean? Okay, Suppose I am taking water molecule. Okay, I am taking water molecule, and water is made up of hydrogen and oxygen. Okay, and they are in the ratio means 2:1, means 2 hydrogen and 1 oxygen. Okay.
Yes, ma'am. Okay.
Okay, similarly, I'm taking hydrogen peroxide, H2O2. Hydrogen peroxide formula is H2O2. It is also having two substance, that is hydrogen and oxygen. What is their ratio? There are 2 hydrogen and 2 oxygen. So this
OH to
statement
2.
says that it will be in a simple whole number, that whole number 1, 2, 3, like this. Okay,
Yes.
it will not be like this, that 1 1 and 3.5, or 2 or 2.5. It should be in a whole number, 2 is to 1, 2 is to 2, 2 is to 3, or 1 is to 3. Okay.
Okay.
Okay, got it. Very simple. Write this example. I am writing the meaning of this postulate also, so that you remember in this in future also. So what does this statement say? This means this means that when atoms join together to make a new substance, means when hydrogen and oxygen are joining together to form water molecules, when atoms join together to form a new substance, to form a new substance, here it is water molecule, or we can say a compound. This whole water molecule is known as compound. They do so in a way that can be counted using simple whole numbers. Which type of whole number? Like 1 is to 1, 1 is to 2, 2 is to 3, etc. etc. It can never be, it can never be complicated fractions. Like 1 is to 1.7 or 1 is to 21. Not like this. Got it?
Yes, ma'am.
Written?
I'm right.
Okay. Written? Yes,
Yes,
Sakshi,
ma'am.
you have joined in this class?
Yes, ma'am. Good evening.
Good evening. Okay, you're coming after so long.
Yeah, I have like exams are coming up. Like dates are given, but the exams are very near. They gave it at last moment
Okay. From when your exams are being started?
from 13
13th. What is the syllabus of the chemistry?
chemistry. This chapter only.
Okay, only one chapter is coming.
Like, is atom around us pure?
Okay, we are having atom around us here, but we are teaching this called atoms and
Sorry,
molecules.
sorry, atoms and molecules are coming. Yeah, yeah.
Yeah, yeah. Okay, but Sakshi, we have completed little bit 25% of this chapter. So how will you
Okay.
complete it?
Like teachers are even in my school also almost this chapter is finished.
Okay, it means you have an idea. You have a background of this chapter. Okay.
Yeah.
Oh, okay, let it be. So Sakshi, we are here. Postulates of the Dalton's atomic theory. Okay, we have done almost, I think, 1, 2, 3, 4, 5 postulates. Okay, the fifth postulate is atoms combine in the ratio of a small whole number to form a compound. Means when water combines, it is formed from two things, hydrogen and oxygen. Okay, it will always be a two hydrogen molecule and one oxygen molecule. It can never be like this 3.5 hydrogen molecule and two oxygen molecule. Okay, it can never
Yeah.
be like this 2.5 in hydrogen or 3 is oxygen. Okay, their ratio is always fixed. Okay, if the ratio is disturbed, then the given compound will not be the same. Okay, it will become something else.
Yeah.
So this line states that when an atom join together to form a new substance, they do so in a simple whole number. Okay, this is a whole number. Okay, not fraction. They can be 1:1, 1:2, but never be like this 1:1.7 or 1:21 like this. Okay, got it? Yeah, Abdul
Yeah.
Hakim, you also got it?
Yes, ma'am.
You can also on the camera. Okay. Now again, the last postulates I am writing that the relative number and types of atoms. Sakshi, you take out a new fresh page and start writing. Okay.
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 Ma'am, so could you send the PDF of the before one?
Okay, I can send it.
Okay,
Okay,
thank
I
you.
will send.
Yeah.
Okay, the last postulate is the relative number. You have to learn all the postulate in a line by sequence. And again saying they will not ask full postulate. They will just ask what is the fifth postulate, what is the last postulate, what is the first postulate. Okay.
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 The relative number and types of atoms are constant in a given compound. What does this mean? This means that suppose I'm having NaCl. NaCl. No matter where does it come from, a mine also, lab also, or ocean. NaCl is a salt. You already know this. It is a salt. Okay. It's a pure table salt NaCl, and no matter where does it come from. Okay. But every single particle of this molecule will always have a one sodium and one Cl. Okay. Suppose if we change the number of NaCl like this, 2 Na and 1 Cl. Okay. means the ratio is 2 is to 1. Then you are no longer dealing with the table salt, that is this NaCl. You have completely created a different compound. Okay, or we can say a compound has to be fixed recipe that never changes. Okay, got it?
Okay.
Okay, so this postulate just tells about that specific compound will always be made up of exactly the same element in a same proportionality count. Okay, okay. Me
Okay, ma'am.
NaCl, you can take NaCl from any of the sources, mine, lab, ocean, or in the home. You can take anywhere. They have exactly one Na and one Cl. If you change the ratio, then the whole compound will be changed. It will no longer be a table salt. Okay, got it? Shall I make you write this or you understand?
Understand, ma'am.
Yes, Abdul Hakim, you tell. Shall I make you
Uh,
write this?
yes, ma'am. I didn't understand it that way.
Okay, it means that write fast first. Okay, this means data. You also write Sakshi. If you will write, you will be more clear about this. It means that a specific compound will always be made up, will always be made up of the exact same element in the exact same proportion by count. Suppose I am having suppose I am having a pure table salt. The salt you used is usually NaCl. Okay, it is also known as the table salt. Okay, it can be manufactured from many of the sources. We can manufacture it from the lab, we can manufacture it from the mines, we can manufacture it from the ocean also. When water is evaporated, then we are left over with the salt. Okay, so these are the
Okay.
sources of the salt that you used in your home. Okay, and it is made up of the exact same molecule, that is Na and Cl. Okay, and it must be one Na and one Cl always. Okay, simple definition it is. For example, write first Abdul Hakim. Okay,
Okay.
if you are having a pure table salt is known as sodium chloride, NaCl, sodium chloride, that is NaCl. No matter where it comes from. Okay, it will always be. It will always have one sodium, that is Na. Sodium short form is Na, and one fluorine atom, that is Cl. Its formula is always NaCl. Okay. If you change the number of atoms, if you change the number of atoms, what does it mean? For example, replace sodium with potassium. Okay. we change the number, or the number ratio means it is not 1:1. It can be, for example, having 2Na and 1Cl. Okay, then you are no longer dealing with the table salt, that is NaCl, sodium chloride. Then you are no longer dealing with that is we have completely created a different compound. Completely created a different compound. Written? Got it or not?
Yes, ma'am.
Yes, ma'am. I got it.
Okay, very good. Now we are going to study the atoms, its sizes, its mass, and the symbols. Very interesting. Okay. So write the heading. The atoms, its size, what is the mass of the atom, what is the symbol of the atom, all these things. Okay. As you all know, atom is very small. Okay. Atom is very small in size. Okay. But Dalton told that atom can never be created nor be destroyed. Okay. In the postulate, it was there atoms can never be created nor be destroyed. But further studies has been taken out, and further scientists work on this topic, and they conclude that atoms can be destroyed. Okay. Also, atoms have some atomic particle. Also means atom is this much small, but the scientists are able to find that atoms have more subatomic particle. What are that subatomic particle? Tell Sakshi, you have done it in your school.
Yes, ma'am.
What are the subatomic particles of atom?
Like measurement you asking?
No, no, no. Atoms can, in Dalton's theory, Dalton was saying that atoms can never be created nor be destroyed, nor it is having a more substitution. Okay, but after the studies has been taken out and the more scientists work on this atom, they conclude that atom can be divisible and atoms has also subatomic particles. What are that subatomic particles? They are proton.
Proton, neutrons,
Yes.
electron.
Protons, neutrons, electrons. Got it? Don't be confused with the Dalton theory and this theory, okay? They are both different theories, okay? Okay. Written Abdul Haqi?
I'm writing, ma'am.
Okay. So atoms are this much small that if you take in millions of particles, okay, 1 million particle you are taking of atoms, okay, suppose I am taking 1 million atoms, okay, 1 million atom and they are stacked, okay, and they are stacked one over the another, 1 million particles. Then also they are having a thickness of a paper. Can you imagine how small is this? Can you imagine?
No,
If
ma'am.
if you just take 1 million particles, ones, tens, 100,000, 10,000, lakh, 10 lakh, crore, and 1 million. This much particle of atom also. Then also, if you put it like this, or one over the another, then we are left with a sheet of paper. This much small the atoms are. Okay, and scientists are able to take out that this paper size atom can also be divisible, and it has a subatomic particle of proton, neutron, and electron. How grateful, how amazing it is. Got it?
Yeah.
Got it or not?
Yes, ma'am.
Yes. So if somebody asks you what is the atomic radius of the atom, so write atomic radius. Okay, atomic radius is measured first of all in nanometer. Nanometer. Okay, what does this nanometer means? 1 nanometer is equal to 10 to the power of 9 meters, or we can say 1 by 10 to the power of 9 is equal to 1 nanometer.
Ma'am,
Got? Or we can say 1, yes, 1 meter is 10 to the power of 9 nanometer. So you have to, yes, Sakshital?
ma'am, -9, it's like 10 to the power 9, no?
No, no, no. -9 means 10 to the more less than 10 to the power of 9. Okay. Very, very.
Oh,
If a number is having a minus sign and some other 10 to the power minus 8 to the power means it is like this. Okay, I'm telling. Means it is like 0.0000009 times 1.
okay.
Okay, means it is less than 1. Got it? Less
Yes,
than
ma'am.
0.1 also. Very small value it is. Okay, and if something is written like this, 10 to the power of 9, it means we can also write this 10 to the power of, we can write 10 in the upper portion, and this 9 will be become like this, -9. These
Yeah.
both are same. Okay. If you want to convert this, you can convert 1 upon 10 to the power of 9. If this value goes up, there will be a negative charge. Sorry, negative sign. Got it?
Yeah.
Yes, ma'am.
Yes. Written?
Yes, ma'am.
Okay.
Yeah.
Right, next heading. Modern. Modern day symbols of atoms, different element. Okay, now we will learn about the symbols, how this particular element is being written in a short form. Okay? It is very difficult to write the whole name of that particular element in the notebook. Okay, so scientists have taken out this solution and they start using symbols. Means aluminium. Okay, this is okay, but we can write like this also. Okay, done. Understood or not? So who take out this thing in his mind? Okay, so Dalton was the first scientist. He was the first scientist to use symbols of element. Okay,
Okay, ma'am.
okay. He was not
Yes.
having idea that I will use aluminium as like this Al and carbon like this. He just used because he was a very ancient scientist. Okay, he used to do like this. He used to make circle. Okay, If I'm a Dalton, I don't know what is calcium or what is sodium, and it is very difficult to write the whole name every time. So instead of writing calcium, he used to write like this, circle. Okay.
Okay,
Okay.
ma'am.
But many scientists came after him. They give another names, another symbols. So after Dalton, Berzelius was the scientist who suggested that the symbols of the element can be made from one or two letters. Okay, that's why calcium is written as calcium. Ca means two letters are used. So Berzelius was the scientist who tell that elements can also be written not like this. We can write the name either one letter or either two letters. Okay, like carbon, he can write like this. Okay, carbon. Nitrogen. Instead of Ni, we can write N. Okay, this Ni will be nickel. Okay, just to avoid confusion, nitrogen is written just N and nickel is written Ni. Okay, calcium is written Ca, first two letters, and carbon also having Ca, so it will be same if we write like this. So we use carbon as like this only. Got it or not?
Yes, ma'am.
These are very basic things, but you have to remember the name. First one, the Dalton. Dalton was the writer. Dalton was the first scientist who used the symbols. Okay, he used to made circles to represent elements. Shall I made it right? Okay, no problem. Write it fast, very fast, because very big chapter it is. Dalton was the first scientist to use symbols. Sakshi, are you able to understand
Yes, ma'am.
properly? Pure.
Yeah.
Yeah, you, Abdul Hakim.
Yes, ma'am.
Okay, he used circles to represent element. Okay, but every time using circle is not convenient. He's taking any element and he's just marking like this, circle. Okay, so it is not very convenient way. So next scientist came, that is Berzelius, Berzell, sorry, L single Lius. Berzelius suggested that the symbols of the elements can be made from one first letter, one to two letters. Okay, two letter of the name of the element. Simple. Written.
Yes.
Shall I change Abdul Hakim?
Yes, ma'am.
Okay. So I am writing some name and their symbols. Okay. So we are having first name, that is carbon, nitrogen. Okay. Calcium, aluminium. Okay. Its symbols carbon. It can be written as C, nitrogen as N, calcium as Ca, and aluminium as Al. Simple. Okay.
Yes.
Chlorine as Cl. No, sometimes not the next letter is written. Sometimes the third letter is used. Okay. Instead of C chlorine, we can write also like the CH. But sometimes, but not like this. Scientists use or prefer to write like this: Cl, third letter, first letter, and third letter. Got it? So
Yeah.
that's why
Yes,
chlorine
ma'am.
is written as Cl and magnesium is written as not Ma but Mg. Okay. You can ask now, ma'am, then why sodium is written as Na, not acid? Okay. Why potassium is written as K instead of PO? To
Ma'am,
avoid
also,
yes,
silver also Ag.
yes. Gold also AU. It's because scientists have some elements. Scientists take out that some elements can be derived from the Latin words like this. Wait, I'm showing you how. First of all, write the symbols. The symbols for some elements. The symbols for some elements were derived from their Latin words. Means I'm showing you, wait, from Latin words, German or Greek names. For example, I'm making a table. Um, I'm writing English name of the element. First column, make a column. Second column is Latin name of the element. And similarly, make third column symbols. I'm writing the name of the element like sodium, potassium. Okay. So Latin name of this sodium is natrium. Okay. The original Latin name of the sodium is natrium. Potassium has kalium. Potassium is known as kalium in Latin language. That's why we used to write the symbols like this. Sodium is usually write as Na and potassium is usually write as Ka. Understood?
Yes, ma'am.
Yes. Similarly, iron. Why we are not writing iron like this I, R or simple I or simple IO? Because third letter is also taken na I won't know, because the Latin name of iron is ferrum, Ferum. So the symbol scientists are comfortable is Fe, first two letters. Got it?
Yeah.
Yes.
Yes, ma'am.
Similarly we are having sorry, similarly we are having copper. Okay, its Latin name is cuprum, Cuprum. So that's why they are written like this. Cu. Silver. Its Latin name is argentum. Argentum. So we write the symbol like this Ag. Abdul Hakim, where are you? I'm not able to see your face.
Yes, ma'am. I'm just putting my phone in the charger.
Okay. You can say, ma'am, please stop it. I'm writing and you
No,
are
I'm
not.
in the room. No, I'm in the room. I'm listening. I'm also
You're
writing.
listening me or not? Come. Then I will write the next.
No, I'm finished.
Yeah. Good, Sakshi. Sakshi handwriting is very fast, like me. Good.
Yeah.
Mom finished.
Fairness, Abdullah, very good. You are also having a very fast handwriting. Good. So, just like we can have gold. Gold can be written as gold. Latin name is aurum. Aurum. That's why gold is written like this. First letter of the Latin name A and U. The scientist has taken, and the symbol of this atom is A. U. Mercury. We are having lead, tin. Mercury has a Latin name of Hydra. Hydra. It is all, everything is present in your textbook. Okay, just go through the textbook daily after learning from me. It will be very helpful. Lead, plum, plum, bum, plum. That's why lead is written like this. Pp. Tin is written like SASTA sternum. That's why 10 is written SN. Means fourth letter is taken. Here it is very interesting that first letter, scientist has taken the first letter of Latin words of 10 and the fourth letter. Previously they were taking first and second, then first and third. Now they are taking first and fourth also. Okay.
Yes, ma'am.
Yeah. Write it, then I will tell you next topic.
Done, ma'am.
Yeah. We have light charger.
Finish, ma'am.
Okay, wait. Battery has gone. Okay, the next topic is modern symbol. Modern symbols of elements. All these symbols of element you have to learn by heart. Okay. Tomorrow in the next class, I will take any element and I will say what, and I will ask you what is the symbol of this particular element, because all these things are present in your book. And your NCERT textbook is very, very important.
Yeah.
Okay.
So till now, I told you that the modern symbols of the atom are derived either from the English or the Latin names. Okay, this much is clear. Okay, so in which the either of the first letter or the first or the second letter or the first or the third or the preceding letters have been taken to form the element. Okay, but here are I'm writing this again. Make a column. First of all, make a column. Name of the element.
Ma'am, is it that one, the symbols like we have to draw instead of writing?
No. We will just write the symbol. No need to draw the elements. Okay. Just first make this table.
Okay.
Okay. Name of the element we are having symbol. It's Latin name. LETIN Latin name. The first element is hydrogen. Already know it is H. It's very basic, but it is present in your book. That's why I'm making you write. There is no Latin name of hydrogen. That's why it is only written as oxygen. Another is oxygen. Okay, this oxygen. Okay, there is no Latin name of oxygen. That's why it is written as oxygen. Boron. It is written as B. Carbon. Right fast. It is written as C. And fluorine. It is written as F. Iodine. I. Nitrogen. N, phosphorus, P, sulfur, S. How barium is written? Tell Sakshi. Barium?
B.
No. Ba.
B.
Please don't forget. Ba. Abdul Hakim, tell how iron is written.
Fe.
Very good. How gold is written, Sakshi?
Ma'am, Ku.
What?
Ku.
No, Au. Okay. Iron Latin name is just now tell you it is ferrum, Ferrum, and there is no Latin name of these elements. That's why we have chosen the first letter for their symbols: boron, oxygen, hydrogen, nitrogen, phosphorus, sulfur, barium. Okay, gold is written as AuRum, Adam. Done.
Yes,
There
ma'am.
is a one element that is that is tungsten. After that, gold first, right? Silver. It is usually written as Ag. Why not Si? Because its Latin name is argentum. Argentum. Okay, Abdul Hakim?
Okay, ma'am.
Okay, I'm writing a element that is tungsten. Tun, sorry. Tungsten. Okay, tungsten. Its symbol is very weird. That is W. Okay, and it is not having what we call. It is not having a Latin word. This tungsten W has been taken from the name Wolfram, which is a German name. Okay, okay. In
Yes,
German,
ma'am.
tungsten is said to be Wolfram. That's why scientists has taken the letter W to write their symbols. Written?
Yes,
Yes, ma'am.
Lead I have already make you write, okay? Lead, tin, everything. Mercury, right below that, okay? I am not having any space, that's why I'm writing this. Mercury. It is written as Hg, and its Latin name is Hydragram. Hydrogrum. Phosphorus is written as P. Sodium is Na. You already know. Its Latin one is natrium. Potassium is written as K. Its Latin one is kalium. Kalium. And tin. Is written as Sn. Okay, because its Latin was is stannum. Stannum. So two and the fourth are sticking. Uranium. All these elements you have to know by your heart. Zinc,
ma'am,
red.
for potassium, what you wrote the Greek word, Latin
Okay,
word?
okay, wait. By mistake it is.
Okay.
Potassium is kalium. Kalium.
After potassium, what you have written?
After potassium, it is tin. Tin. Its symbol is Sn.
Done.
If somebody asks you, Dilhakim, tell what is the significance.
Ma'am, can you go back? I didn't see the last
Okay.
the number. Okay, ma'am.
Okay, if somebody asks you what is the significance of symbol, why you are making symbol, why you are writing symbol of any particular element? Because symbol tells about the first of all name of the element. If I'm writing night N, so you will automatically know that I'm talking about nitrogen element. Okay, if I'm saying Hg, then you will automatically will be known that ma'am is talking about mercury. So what is the significance of writing symbol of any element? Significance is that first of all we will get to know about the name of the element. First of all, we will get to know about the name of the element. Okay, Sakshi?
Yes,
Okay,
ma'am.
you are having a nickname. You are having some nickname in your house?
No.
Okay, if I am saying that Sakshi is any nickname?
Any.
Okay, no problem. In my house, people used to say me Aishu, Aishu. It's my name is Aishu. Then I'm automatically somebody is calling me Aishu. It means that they are calling me means my full name that is Aisha. That's why if I'm taking a symbol N, if I'm writing N, then you will automatically be known that ma'am is writing the element nitrogen. So what is the significance of symbol? The significance is we will get to know the name of the element automatically. Okay. And what other thing? An atom of the element. Atom of the element. It means, what does it mean? It means I'm taking, for example, I am writing a symbol N. What does it stand for? It stands for that I'm taking the name of the element. What? Which element? Nitrogen. And an atom of the element nitrogen. Means I'm talking about the atom of that also. Atom. Atoms are the substances that this nitrogen is wholly form. Okay. Wait a minute. Call is